Okay, thanks a lot for inviting me to speak. So today I'm going to be talking about these procedures for generating different ways for generating and evaluating 3D models, mainly focusing on the generative part. So a quick overview of the presentation. So the presentation is focusing on estate planning and developing computational tools and workflows to support estate planning. And the research that we're talking about is a project that we've been doing together with the Land Planning Division at JTC. So it's between NUS and JTC. And the research is focusing on the planning of industrial estates for JTC. So when JTC are planning these estates, there are a complex set of detailed planning principles that have to be applied. JTC has created a document describing these planning principles in quite a lot of detail, and they contain a lot of rules about density, about setbacks, about program types, about cycling lanes, greenery, a lot of different rules controlling how these estates are planned. And the rules are applied to an idealized estate, which is an idealized square, perfectly square estate with a center in the middle and sub-nodes around the edge. Now, of course, in reality, land does not come in perfect squares. Land comes in funny shapes, and there are streets going through it. So the process of applying these rules and adapting them to a particular context is actually a very time-consuming process. And if you then want to look at alternative scenarios and try out different options, you end up having to do this over and over again, and obviously that is very time-consuming and needs to be automated. So the automation process that I'm going to be talking today is how to generate, given a particular context, how to apply these planning principles to automatically generate 3D models of these estates. So in this presentation, I will be looking at two different tools. One, the S3 tools, ArcGIS Pro and City Engine, which I think most of you are familiar with, and then another tool called SideFX Houdini, which is a procedural modeling tool, which has a kind of visual programming language that allows you to create procedural models without having to do any coding. And so the SideFX Houdini tool is something that has come from the animation industry, but we have been, and it's used a lot in creating movies and things like that, but we are using it for the procedural power that it has for generating these urban models. So the case study that we're looking at is a 1,300 hectare area, on which there would theoretically be 3 different estates planned. And so this area has a particular shape and has some streets going through it, category 1, 2, and 3 roads. And the challenge then is to take these planning principles and apply them to this area to generate 3 different estates. So the way that we do that is that we start in ArcGIS and we end in ArcGIS, and in between we have this workflow that ties together a number of different tools. So it's really using the best tool for a particular stage of the workflow, but then at the end everything starts in a ArcGIS Pro and ends in ArcGIS Pro. So the geospatial data that we start with, we create certain specific layers, then take them into Houdini, where we generate the 3D model, generate the 2D models. So in Houdini, we're mainly generating the 2D models, and then we're taking the 2D models into City Engine, and then generating the 3D geometry from inside City Engine and taking that geometry back into ArcGIS Pro as ArcScenes. So if we start with the modeling workflow, just to give you some idea, I'll go through the modeling. I'll go through some videos later that explains individual steps. But first, just to give you an idea of this workflow, in the next few slides, the main steps of the automated workflow will be shown. The process starts in ArcGIS, defining the kind of minimal inputs that the planner has to define. So the first kind of input is just the streets that are not going to change. So these are the streets that are going to stay fixed. They're not the generative process is not going to change these streets. The second input is the urban node. So each one of these of these industrial estates is centered around an urban node, and at the urban node, there's a kind of mixed-use buildings with a higher density, and then surrounding the urban node is all the more industrial buildings, the B1, B2 type buildings. So the planner defines where these urban nodes are, and also where a set of sub-nodes are. So by defining these points, that gives the planner some control over what then gets generated at the next stage. So then the first part in the generative step, the Houdini gets used to automatically generate the street center lines and urban blocks. So this whole process going from this stage to this stage is fully automated. So it generates the street center lines and urban blocks. Then in the next stage, it subdivides those urban blocks into plots for buildings, and the subdivision is kind of carefully controlled so that the plots that are close to the urban centers are smaller than the ones further away, and the way the divisions happen is as much as possible perpendicular to the street, so that when you get buildings, they are facing the street. There's no kind of strange plot shapes. And then we can generate buildings in a number of different ways. So we can either generate buildings in the Houdini tool or in the City Engine tool, and the two approaches have slightly different kind of ways of working. So they're really just two alternative ways of generating the buildings. And then we also have the streets. So we take the street center lines and then use City Engine to generate the streets following LTA guidelines. And then finally, we take the 2D building footprints and generate 3D buildings from them using City Engine. But the buildings are really we're not trying to generate detailed buildings. We're trying to generate massing that is really informing the urban planning process, rather than generating buildings with windows and textures and everything. So looking at this whole process, when we look at this sequence of steps as a kind of flow chart, this is what the flow chart looks like. We start in ArcGIS, we go into Houdini and generate plots and streets. And then once we come out of Houdini, we have two different kind of paths that we can follow. The top path, the one you see on the top there, is creating the plots with City Engine, creating the building footprints with City Engine, and the bottom path is creating the buildings with Houdini. The middle path is the streets, and then everything comes back together again in the 3D model in ArcGIS. So let's have a look at this procedural modeling in Houdini first. So I have a series of videos that just go through this process and explain what's happening in this. So it's really looking at these two parts in the flow chart where we're using Houdini. And so if we look at this, this is the data that gets generated at the end of this process, is basically the street center lines, the blocks, the plots, and the building footprints. So each one of these processes is fully automated, but also the planner can go in and edit things as it is being generated. So if we first look at the main generation process, which generates the overall kind of plan of the industrial estate, we can see that there's a kind of the three urban centers, and around those urban centers there are the sub-centers, and the planner can change various parameters and go in and can move certain points. Let's say they want to move one of the sub-centers slightly, then the model will update automatically. Then they can also go in and edit particular streets, so they can add streets if they want to add a street somewhere, or they can delete streets or adjust the position of streets. So these are, the model gets automatically generated, but the planner can always go in and edit the information that's being generated. Then editing street width, so the streets are all developed based on LTA guidelines, but they're depending on the width of sidewalks and those kind of things. You can actually still go in and edit the street width. So you can, when you change the width of a particular category of street, cat 2 or cat 3 or 4, then all the streets of that category will be changed automatically. The setbacks will change and the plots will change. Then the other part that is quite critical is the around these urban centers, each zone has a different kind of building program and building type. And so the planner can change the radiuses of this zone. So the radius of the mixed-use zone around the urban center can be changed. And then the radius of the kind of second zone, which is less mixed-use, more industrial, and then the last zone being the purely industrial. So these radiuses can be changed just by changing a parameter and saying, I want to change it from 300 meters to 500 meters. But there are two ways to do this. One way is to do it as was just shown in this video, change the radius. The other way that you might want to do this is where you know in advance the total square meters of a particular program that you want. So if you say for my mixed use zone, I already know how many square meters I want, and I want the computer to tell me what the radius should be, rather than me typing in a radius and it telling me the square meters, then you can also do it that way around. So in this example here, the planner just types in the square meters that are required, and then the system will generate the radius based on the plot ratio, the maximum building height, the setbacks. So it works out for every plot what can be achieved and then calculates the radius for that zone. So it automates in a few seconds, automates a process that would be extremely time consuming to calculate manually. Then there are other things you can edit. So you can go in and edit the plot types, similar to what we just saw in ArcGIS Urban. You can go in and select plots and say, I want to change it from one type to another, and that will affect the plot ratios and will affect the total floor area that's produced. You can go in and edit the block subdivision. So once the blocks are subdivided into plots, there are certain, you can set the size of the plots that you want, whether you want your plots to be smaller or bigger. And so that kind of whole process at the end produces different outputs. One output which is the blocks, the urban blocks, one output which is the plots, and another output which is the street center lines. Now the plots that get generated can also be used for generating 3D models, and those 3D models can also be simulated in Houdini's to do certain types of performance analysis. So we have done wind and solar radiation being two commonly performed types of solar analysis. And so by generating, by taking into account the existing buildings and also the new buildings that are generated, we can then do a wind flow analysis or solar radiation analysis. The solar radiation workflow that we have done with this, we actually also used for doing a solar radiation analysis of the whole of Singapore for, with the SLA 3D model for Singapore. We did a simulation for the whole of Singapore. So the scalability of these simulations is very large. So the Singapore model had 152,000 buildings in it, and we simulated each building for the solar radiation on the surface of the building. So then the next step is the streets. So we take the center lines from Houdini and take them back into Cinti Engine for generating streets. And so in this process, we are using Cinti Engine to model the streets based on the LTA guidelines and the JTC street rules. So the JTC will follow the LTA guidelines, but they have their own requirements and their own rules about how the streets should be configured. Our CGA rules that we use for generating streets are based on David Wasserman's set of CGA. They've developed a CGA for developing very flexible CGA for streets, and we've adapted that CGA to this particular context. So this allows us then to create the streets for these estates which match the LTA guidelines, and we can change and edit all the lanes of the streets and the trees and the setbacks, and all these parameters can be easily edited. We can also combine that with the 3D model that gets generated. So while editing this, we can edit the streets while also being in the context of the 3D model, and at the same time we can even select buildings and then edit the buildings as well at the same moment, which I think is shown in the next part of this video. So we can select buildings from in the same model and actually change the buildings as well, or we can change the streets. So then looking at the buildings, the 3D buildings, so we've got two different workflows that we can explore now. But in the videos now, I'm looking at the top workflow, where we generate from the urban blocks, we generate the plots, and then from the plots we generate building footprints, and from the building footprints we generate 3D models. So here we select the plots, and we apply a CGA rule, and the CGA rule then generates buildings on those plots. The buildings that are generated are following the plot ratio. So no matter what settings we are choosing, the plot ratio for the plot is staying constant. So this allows the planner to go quickly generate some urban massing to get a kind of feel of what the density is like, and then to go in and change some of the plots, some of the specific plots, and go and change some parameters and change the 3D massing, but being assured that the plot ratio is always going to be constant. So that example that I just showed was the one on the right side. The one on the left side is a slightly different process where we generate the footprints in Houdini. So in Houdini we have a procedural modeling, visual programming approach to generate these footprints, whereas in City Engine we use CGA rules. So slightly different types of buildings and building typologies can be produced. And so depending on the type of building typology that you want to create, one might be a little bit easier than the other. So then once we've generated all these different kinds of massings and buildings, the visualization step is really looking at taking this data and then visualizing these different models, bringing the data together, bringing the streets and the 3D models together into one model. So if we look at the City Engine viewer, just using the City Engine viewer to bring it all together, we can see that this is the Houdini model where the building footprints were generated in Houdini. And then the next one here is the building footprints generated in City Engine. The two models are actually quite similar. I mean, they're generated on the same building plots. So the street layout and everything is exactly the same. It's just, and the density is the same. It's just slightly different urban fabric. The looking at some future work, what the key aspect, so in this presentation we've really looked at how to generate these urban models, how to generate alternative urban models, and in the future we want to start focusing more on the evaluation part. So at the moment we have a number of evaluations that we can do in the Houdini software coming from the Houdini workflow, but those evaluations are not integrated into this whole workflow. They're kind of an offshoot from the Houdini part, and they're not integrated into the overall workflow. So one area that we'll be focusing on in the future is to look at how to integrate the evaluation of these models into the overall workflow, so that we can take 3D models, evaluate them on the cloud, and then take the results back into ArcGIS Urban and visualize the results in ArcGIS Urban. So the previous presentation on ArcGIS Urban is really where we want to focus on in the future, is running simulations in the cloud and then taking the results from the simulations into ArcGIS Urban so that we can visualize them in ArcGIS Urban. So at the moment, we are developing cloud-based simulations that run with Houdini. So Houdini would be running in the cloud, but for the planner, that would be totally transparent. They wouldn't actually know it's Houdini in the cloud. They just, in ArcGIS Urban, they can just upload their model into the cloud. It gets simulated, and the results then come back to can be downloaded and could just come back and be displayed in ArcGIS Urban, so that the whole simulation process is totally transparent. So we're doing that for the solar radiation model and for the wind flow model. The wind flow model is using a dynamic, fluid dynamic simulations, which is gives you very fast results with reasonable accuracy. So in a very short amount of time, you can get feedback on the urban wind flow. So finally, we started experimenting already with these uploading these urban models into the cloud. And so this is the City Engine viewer. We've uploaded one of the models we generated. And so we integrated the streets and the models into it's an initial kind of experiment, not very detailed yet, but we embedded the streets in the 3D model, and you can click on the buildings and get the attributes of the buildings and information about the buildings in this online environment. So that is the final slide. And so thank you very much, and do let me know if you have any questions.
Okay, thank you, Patrick. Now we'd like to open the floor for questions. We have a couple of questions that have come in. The first one is, what data or tool is needed to generate 3D models that can visualize water and or electricity consumption right now to the unit level?
That can visualize water or electricity consumption. What needed to generate 3D? So I think the data is just an attribute. So as we saw with the ArcGIS Urban model, it doesn't really matter what it is. If we want to visualize some statistics, then all we need to know is the data of this thing that we want to visualize. So if it's, whether it's water or energy or the number of people working in the building, it's just a piece of data. So as long as that data is attached to the polygon that for that particular plot, then we can visualize it. And so in ArcGIS Urban, we saw it being visualized as a cylinder with height. And generally, when we are doing this kind of geospatial data visualization, we have two variables that we play with. One is color and one is height. So typically what you can do is visualize two parameters at the same time. So you can say, okay, the height represents the number of people in the building, and the color represents the energy consumption, something like that. And then you can start saying, why is this building, why is this one so tall but red, and why is this one so short but still red? And it allows you to visualize two parameters at the same time.
Okay, thank you. We'll move on to the second one. What is the advantage of using Houdini over City Engine when generating the plots?
So I think the reason we kind of do certain stages in Houdini is when we have a lot of interrelationships. So the CGA rules, let's say you develop CGA rules for one building, but those rules cannot take into account what's happening in the next door building. So the CGA rules for building will generate a building, and then the next building will be another building. But we are looking at the whole estate. So if the buildings get higher in one part of the estate, they have to get lower somewhere else. Everything is connected. So in the Houdini procedural modeling, it's you basically have a visual programming language where you write an algorithm, and that algorithm can connect anything to anything. Any data in one part of the estate can be influencing data in the other part of the estate. So if you make if you add more roads, then you get smaller plots, and then the buildings have to get taller. So everything is interconnected in that way. And so that's where we focus the Houdini part on. And then if we've got a plot and we just need to generate a building for that plot, then we use City Engine, because also the city engine CGAs are a bit more interactive for the planner. They can go in and play with the parameters and change stuff.
Okay, thank you, Patrick. The third question, can City Engine be used for procedural modeling instead of Houdini? And what are the additional benefits of using Houdini?
I think a little bit the same as the previous question. I suppose, I mean, the other thing to say is that Houdini is a visual programming language, whereas CGA is a textual programming language. So it is also a little bit to do with the target audience, and so planners generally are not very open to learning textual programming. So it may also be another consideration that with the visual programming, it's a little bit easier to get into.
Okay, thank you. I guess we have we have time for the one last question. Which one would you personally recommend using in terms of capabilities, ease of use, and customizability when choosing between Houdini over City Engine for plot generation?
For plot, I'm not sure if this question, they are thinking about the plot generation. So we take the building, we start with the streets, then that generates blocks, and the blocks we subdivide to make the plots. So subdividing the blocks to make the plots, I mean, it probably could have been done in both tools. I think it's not such a complicated step. But for the overall process of generating the whole estate, certainly I think it would be, because of the things that I mentioned before, because of the interrelationships between everything, it would be extremely difficult to do it as a CGA. So I think definitely we would prefer to do it in Houdini. But Houdini is also not so easy, so there's no silver bullet, right? So Houdini is also a complex tool and also takes a while to learn.